welcome to the Fiber Broadband Association's Fiber for Breakfast. We're now in our 7th episode of 2026. The gold sponsor for Fiber Breakfast is Conducts. While Congress is in recess this week, today marks the 5th day of the Homeland Security shutdown. Fortunately, the federal agencies that we've worked closely with, such as the FCC and NTIA, are not affected. Last Thursday, February 11th, NTIA hosted their first listening session on potential allowable uses of BEAD non-deployment funds. Over 1,000 participants attended, and several FBA members and ILAs spoke on our priorities, including streamlining federal, state, and local permitting, investing in robust workforce programs, and supporting adoption efforts. The FBA plans to attend NTIA's new second listening session today, February 18th, and will continue to elevate our members' priorities and uses of non-deployment funds. On last Friday, the House released the Farm Bill text. While we're pleased to see the Rural Utility Service Organization codify into law the increased speed standards, we remain hopeful that the future efforts will emphasize the importance of symmetric high-speed connectivity for rural communities. FBA has been a strong supporter of the bipartisan Reconnecting Rural America Act, introduced by Senators Marshall, Welch, and Representatives Nunn, Vadquist, and Sorensen in the House, that would require our U.S. programs to adopt symmetrical speeds. Chairman Thompson of the House Agriculture Committee is aiming to mark up the bill on Monday, February 23rd. As a reminder, the Fiber Broadband Association will be hosting its annual Public Policy Summit and Fly-In in D.C. on Tuesday, February 24th, the same day as the State of the Union, and we'll have our Fly-In on the Hill the following day on the 25th. And at our summit, our members will hear from Chairman Richard Hudson from North Carolina, beat champion Senator Shelby, that's Alabama, Senator Shelley Moore Capito of West Virginia, FCC Commissioner Olivia Trusty, broadband leader, congressional woman Jennifer McClellan from Virginia, NTI Chief of Staff Brooke Dunnelan, Speaker Mike Johnson from Louisiana's Policy Advisor Cyrus Arts, and Chief Washington correspondent from the New York Times, Carl Holst. So I hope you guys can join us. It's going to be a great event, and we'll be there next week. Last week on Fiber Breakfast, our guest was Dr. Tamara Holmes, the director for the Office of Broadband at DHCD in Virginia, to provide an update on Virginia's fiber projects and initiative. Dr. Holmes, great friend of FBA, discussed the tremendous progress that Virginia has accomplished in connecting their states with funds from state and federal programs. If you missed that, you can go to our website and see the replay. Today on Fiber Breakfast, our guest is Michael Thomas of Network Connex to discuss the hidden infrastructure behind AI and hyperscale networks. Michael is the Regional Vice President of Integration Services, where he's responsible for overseeing the ISP systems installed across multiple disciplines and scopes. During his more than 30-year tenure in the networking industry, he's managed inside and outside plant, technical teams, engineering teams, vendors, call centers, interdepartment relationships, purchasing, budgeting, and planning. Michael served in the United States Air Force, so thank you, Michael, for your service. And then he moved into IT in 1992 for a private firm, and then joined Southwestern Bell Telephone, a name I hadn't heard in a while, now AT&T, for a 24-year run. So I guess 30 years was 24 years. So I guess, Michael, you have 54 years of experience. Wow. So he got a bachelor's degree. Michael's like 150 years old, if you hadn't noticed that. But, Michael has a bachelor's degree in business management, information technology from Western Governor University. So with that, welcome, Michael. And for our audience, please type in your questions as we go.
Thanks. Appreciate it very much, Gary. Thank you for the introduction. And yeah, not quite 150, but yeah, that 24 laid into that 30 plus for sure.
Okay. So. All right, we'll let you kick things off.
All right, cool. So I just wanted to start talking about ILAs really quick. So this has been kind of a hot topic of discussion, and it really kind of aligns with the hyperscalers like we were talking about before. And just to kind of give you guys an idea, right now I'm in Abilene, Texas, where this Project Stargate has gone, this huge AI build. And we have teams out here that are actually doing the builds, and we have teams connecting these things together with the ILAs, turning up the circuits where we connect these data centers together, right? So it's a critical part of how this goes. And we'll get into like how those things work here in just a second. When we lay out the fiber itself, or I mean, when they lay out the fiber itself, they have to amplify that signal. And that's what the ILA is. It's an in-line amplifier, which is typically located in a hut, just like these that are shown here on the shelter. We, at Network Connex, we build these things out and we plan them and help do design and all of that stuff as well. And there's just different stages of that. So just kind of a real quick rundown of what this critical component of these things are, and what it takes to kind of build them. So these are what typical double-wide shelters actually look like. There's a couple we placed recently. If you go ahead and change the slide. Now, the key components here are, we got to figure out kind of where and how we're going to implement these things. So the where is, the fiber as it goes, you're shooting light down the fiber, you have attenuation or loss, right? And we've overcome that in the past by regenerating signal. That's where you take the light, you transfer it to electrical signal, and you recreate the light signal and retransmit it. That creates an entirely new, clean signal. But the problem is that transition is channelized and it takes time, and we have enormous amounts of bandwidth that we're trying to transport. So we can't get into that. So what they've done is come up with some technology that was from back in the 50s and kind of perfected in the late 80s, early 90s, where we amplify the light kind of in an analog sort. We insert photons. It amplifies the light. So that amplifies the signal, and it also amplifies the noise, right? So that's where the ILAs come in. They have to be a certain distance apart because of kind of a noise budget, right, or a loss budget rather, overdue. Because if you amplify signal and you amplify noise, you let that noise and signal get too close together, you amplify them both, that noise just keeps stepping all over your signal. So you're going to keep them close enough together where your signal level and your noise level are far apart, so that delta is amplified as well, so you don't have to worry about noise issues as you go forward. So as you can see on here, there's a map with a green line that just shows like a typical fiber route, and in a circle along this route, those circles are a general area, and they're roughly about 50 miles apart, right? The loss budget for attenuation is about 23 dB as a not to exceed. And that roughly equates to about 80 kilometers or 50 miles, 50 to 55 miles. It's not an exact science. They can be placed a little bit closer or a little bit further away from the other one than they have to be. It just kind of needs to be in that budgeted area. Once they set it down, they actually come back and then we look at the actual design for the inside of these things and how that's going to look with the number of fibers that they're going to be using, where it's going to be located, what the climate is, and all that stuff. So we actually have those things engineered. We do all this stuff internally, but we have all that planning and engineering done. Go ahead and hit the next slide there. So part of our system, once we actually have these things identified and they pick a piece of land, buy the land, we go out here and actually do the construction on it. That we have civil crews, we go out here and make these things actually happen from the middle of nowhere. Go ahead and hit the next one. Once we set the things, set the foundations down, we come in and actually set the shelters down. A lot of these things are pre-configured in a lot of ways on the inside as much as we can, and externally to prevent an amount of time out in the field getting these things installed, and really getting really efficient about putting them in. But this is just some pictures of actually how, we take and crane these things over, they join them, and then, put them together. And then the last one there is the internal fit out. So there's various configurations of this, but in all reality, we're talking about a mini data center, right? A little mini colo data center that's sitting out in the middle of nowhere that runs between 17 and 200 racks, kind of depending on what the use case is and what the customer's needs are. And we engineer all of that and get all this stuff installed. And these, a lot of these right here, you're showing DC power. That is the preferred power of choice on a lot of these things as well, just for the stability and kind of getting back into that old telco type mentality with regard to stable power and utilizing the DC just because it's cleaner. Plus, when you install it, it looks a lot prettier, right? So, all right, that's kind of the whole rundown on really kind of how they're implemented, right? And it's a really kind of a high level, 30,000 foot view of that. There are a lot of other factors that go into that, that we support. So, be happy to take any questions on that itself. So,
Well, Michael, let's start with, you're down in, I'm picturing what is it, Billy Bob Thornton kind of scenario where you're down as landman there in Texas at Stargate. So you guys are all living in a big house and so this is a $500 billion project. Can you describe what Stargate is at high level, and then kind of how these in-line amplifier huts how they're using that as part of that project?
So Stargate is a very large campus build. I believe it's the largest campus build in the world, if not one of the largest in the world now, because there's so many going these days. But it's multiple buildings that are interconnected, right? And they have the GPUs that they're using for the AI in these buildings, but they're just connected together, right? So it's just like one massive computer. Where the ILAs come into play is on campus. In these places, not just here, but elsewhere, you have multiple buildings that are interconnected with fiber optics on campus. Well, those are very short, right? You don't need any amplification or anything like that. The loss budget on those is non-existent because it's only going a few hundred, yards. When you go from here to the next place over, that's in, let's just say, Louisiana or in Nevada or wherever, that long haul fiber, that's where that loss comes into play. So when you shoot that light to that, out of this facility to go to the next facility, they run the fiber out. They've got to put these amplification shelters on that link the entire way, roughly every 50 miles, to maintain the level of signal to get back and forth. So now, once those things are there, it connects two of these campuses together, right? And then it's just going to turn into like this web of campuses or campi turned together as well.
So, the biggest cable I've seen is 6912, so 6,912 fibers. What comes into these ILAs?
Boy, it really varies. A lot of times we're dealing with 864s. The 6912s, I haven't seen one with those yet, but I'm not saying that's not outside of the realm of possibility of coming into them. But typically they're not that large when going into these sorts of things, because the size of the huts limit the amount of fibers you can actually amplify just due to the space and power required for the electronics, right? And understand that these things are in these small 24 by 36 huts that have a very limited ability to provide cooling capacity, and they're out in the middle of nowhere. So there's like a large power budget to spend money on power to get 3-phase power out to these places a lot of times. So it's pretty interesting.
So in these huts, these are largely line amplifiers, right? So this is really just regenerating the optical signal to transmit. So you're not full of GPUs or anything like that. You're not doing any large language models or any kind of generative AI.
No, don't. There's strictly amplification and connectivity. There has been some use case on proposed use case for edge computing, but it would not, in so far as I've seen, has not been, nor would there be any AI GPU placements, for example, in these.
Okay, so this is not a distributed AI data center, but it's largely for just being able to move as you connect these large data center campuses. You're just being able to regenerate the signals about every 50 miles.
Right, and you got to understand too, we're talking about a power budget, right? So power and cooling. If I have these things, I have a limited amount of power and cooling, I'm going to make absolutely certain that it's doing the task that it needs to do. If I use that power and cooling for some other function, I lose capacity on the ability to amplify, right? So that's where we need to make sure it kind of stays into that. Now, that being said, there has been a lot of chatter and use case about providing potentially connectivity to like rural ISPs and WISPs and things like that, or communities where they have like this band, like I said, these things are going through the middle of nowhere. Or I say that, well, they're going between large cities. So there's like a lot of rural area. So in these rural areas, they could actually have potential connectivity points in there where they could actually get connectivity into that bandwidth that's just passing right by them, right? I mean, there's just a information superhighway running right through the middle of it. So there's the potential of tapping into that.
All right, so there's a whole whack of technical questions here. So
Yeah, I see that.
Totally sad. You can see what happened. All right. So this one comes from the audience is, are you running coherent DWDM technology for the long haul network?
So that's outside of my expertise. I'm going to be honest with you. So that's in the technology space for how what the electronics are using and what they're actually transmitting over the fibers. And frankly, while I'm very well versed in integration and all of that, that's a discipline that I'm not experienced.
What about the power requirements for these ILAs? So what are you doing for on-site generation?
So typically right now they're relying on commercial power for most everything that they're doing. And the power budget really varies depending on what the size of the shelter is, and the design of that and the design and engineering of these things actually begins at that power budget, right? How many cabinets and how many amps and all of that all drives into what the power budget's going to be. Once we establish what that is and we get from the commercial power companies then we turn around and have generation on site for failure, right? So you have diesel generators are primary. I've seen a couple of gas generators, but there are new technologies coming out for on-site power generation that we're looking at. I don't know a lot about them yet. I just started to kind of dig into it, but it's really exciting that you could wind up having potentially a natural gas or a propane connection at a facility and generate all the power you need for that facility without any external connections whatsoever.
And then there's a bunch of quantum questions here, but have you seen interest in higher capacity or higher quality ILAs in support of quantum networking equipment?
I have not heard of any quantum equipment that's out there in the ILAs themselves, because they're typically the ILA electronics. I don't want to say that's old technology, but it was developed in the 50s and the 70s and the late 80s when it's kind of perfected and employed, and then really into the late 90s and 2000 before it actually really got legs, right? So it's as far as like different types of electronics that they're going to use to do that, I'm not going to be able to know. I'm not going to be able to
when you put the ILAs, you're talking about 50, 80 miles apart. What factors might push that distance longer or shorter?
And that's a good question. So when we're doing the site acquisition for these things, and actually in that circle that I was showing and kind of determining what that area is going to look like, where that thing is located is really based on what land is available for purchase. What does the land look like? How much is there power available to it? Is there something that we can use? There's a lot of factors that go into that, but it's really just the physical land piece itself and the ability to use that within that circle or that budgeted space.
So given, this whole AI is eating the world, are you seeing that the designs of the ILAs have changed much?
The designs on ILAs have not changed tremendously. We are starting to see some compression in like the electronics and miniaturization. So we're starting to have more power consumption per cabinet on certain builds that were being asked for. That sort of thing is starting to happen. I know that they're looking at like hybrid types of these. Again, the technology and the electronics internally, I'm not that aware of, but I do know that they have hybrid amplifiers that they can, shoot over longer distances and, higher density, that sort of thing. So there are changes that are occurring as we speak. It's just kind of a very interesting space to be in. It's also kind of, these things are kind of going two different ways as far as their size. We've had people coming asking for very small versions of these, just a few racks, and then we've had them coming in with a couple of 100 racks, looking for basically a little micro colo data center build that would suffice their needs for whatever capacity they had. Kind of going back to your 6912 question.
Another audience question is, do you know the average dB gain when adding an EDFA or a fiber amplifier?
That I don't know the actual average on that, no, sir.
So when you're, what technical innovations, optics, power efficiencies, automation, do you think will impact the ILA design over the next 5 years?
Wow. So that's a lot, right? So the 5 year thing, there's going to be so much activity. One of the things that I can see happening is that there's going to be more of a dependency on on-site generated power, right? I think that's going to become more of a thing. There's also alternative battery solutions that are going to provide some additional support that will lower operational costs. And then I think as we start to see these things in electronics improve, you might start to see them spread apart a little bit more or gain more bandwidth. The types of cooling that we use are going to have to change to be able to support some of the newer, higher density electronics with more power consumption. And again, in these small spaces, that's a real problem, right? You got to remember these things are like these little huts in the middle of nowhere. So you've got 4 concrete walls and a backpack air conditioner on there that's pretty much dependent upon ambient cooling. So there's no really directed cooling in there, no containment. So those sorts of things are going to have to start to be a part of what we do, right, to compensate for those things.
Do you know, today I assume that these are largely just dedicated for these hyperscalers, but given that these huts are in rural America where you need access to mobile wireless and internet and things like that, do you see that these would expand to provide internet connections, or interconnect connections, so that people
Yeah,
can
yeah, so that wouldn't surprise me at all. And I think that's definitely where I think that's definitely an evolution that is going to start happening. I think that the hyperscalers, while they're driving it, they're not really the only people doing it. You've got, co-location companies are big into this as well. And you got to think about it from their perspective too, right? I've got 2 data centers. I'm leasing space in each data center. If I have an interconnected fiber between the two where that's going to drive real estate in both sides of my business there. You know what I'm saying? So the co-locations are in that as well. And when you start getting co-locators in there, then that kind of opens the door more for interconnected services along that route as opposed to just inside both ends.
So lots of questions about hollow core. Are you mostly seeing single mode fiber? Or are you seeing any hollow core demand yet for those?
It's single mode right now. We have a team that handles that. Our fiber team, led up by Shane Abbott's, actually running into all that stuff. So I don't have optics into if they're switched over or how much of the hollow core they're using. But for right now, I know that it's mostly glass.
And when your fiber comes in, do you guys are these all connectorized, or do you guys splice them all in, and then are they in fiber cross connect cabinets, or how does that all work?
That's a very good question also. So no, we have LOSP teams that run the fiber in. It's not pre-connectorized. Everything comes in, cut it in, splice it in, throw it into an LGX, and then demarcation panel. And then whatever, whether it's a colo the customers are, or if it's the customer themselves, they have access to that at that point.
Another question for the audience is, what does the CapEx look like on a typical ILA build?
Wow, it varies just as much as the size and capacity, right? I mean, you're talking, the smaller, lower ends. I mean, you could be looking at right around, close to $1 million. You're looking at things that go significantly higher depending upon the size and scope and all of that, and also some of the design requirements and power requirements from the hyperscaler customers to the implementation customer set we have are a lot, right? And those things can drive significant expense. I've had an instance where we've had just the battery portion of it was well over $1 million, right? And there's, like I said, it's so broad. It really kind of depends on a use case. And the best thing I would just say is you just need to contact, us or somebody that has experience in consulting on these, so you can get an idea of what that's going to look like for your company if you need to have something done like this.
A lot of monitoring questions that come in, like fiber alarm monitoring, what's deployed typically in the site, and just overall bidirectional monitoring. So can you talk a little bit about your fiber monitoring?
So the fiber monitoring is all really typically on the customer. We don't really deal with that or the electronics portion of that, or I don't necessarily. But there is, we do build into these things, SCADA and also alarm access, and all of the stuff that they're going to need to have connectivity to be able to see whatever it is they want to see at any level.
All right. So here's one that's. Where does your responsibility start on the DC property? Is it 0 volt or in the DC meet me room?
Oh, that's a very good question. The DC. So there's a meet me room. All right. So I'm trying to, all right. So it depends on the scope that we're dealing. So if we're actually doing the turn ups on these things, and understand my team goes and we do the builds on them, we've got groups that do all of it. And my team does all the inside plant portion of it. So they go build out the inside portion. And then I have another team that goes and turns up the circuits on, right? So those guys will be going into the DC meet me room, right? That's where they'll go from to turn those up.
Well, Michael, just a lot of information here, kind of questions. So this is definitely an area of interest. So if you're laying out these huts every 50, 80 miles, that's a lot of right away. How do you guys, are you able to find spots that you can put these? What's the footprint of these, and how difficult that is to be able to stay on route and drop huts every 50 miles?
Yeah, well, it can be challenging, right? So
we've
got
a landman, so you got Billy Bob Thornton.
That's it, right? For real. So it's really a, I just lost my train of thought there. All right, so every 50 miles, right? So you're gonna have to ask me that one again. I'm sorry.
Oh, just about being able to get a place to drop your huts. So you're.
Oh yeah. All right, sorry, yes.
Right away.
So, right. So placing all that stuff comes from our actual engineering team. So we have a professional services team that actually puts out and does the OSP engineering for the route. When they do that, they design, and then they say, okay, this is the budget in the circle where that's going to be. And then those go to the site acquisition team that they actually go and do all of that business, where they go find all of those places and put them all in there.
And then they got to have commercial power and all that stuff. So yeah.
Yeah, so they do make sure. Yeah, so there's a few things that they need to make sure that it has commercial power. Obviously, and I'll be honest with you, we've built them on mountains, and we've built them in swamps, literal swamps that are just water you wouldn't believe. So when I say where these things are going to be and all that, it's literally anywhere.
So it's interesting. Last question is, or observation maybe. When I was in Austin, I guess last year or a year before last, they had such a grid issue in the past that they say, no data centers, no, we can't do anything on the grid. Now it's, with the administration change, they're like, bring them on. So are you guys seeing any issues with the grid in Texas to be able to support the world's biggest AI data center?
No, not that I've experienced.
Well, Michael, thank you so much. Thank the audience for a million questions. All great questions.
Oh, yeah.
Thank you for that. Slide just came up with our next regional Fiber Connect workshop. We had an amazing one, Oklahoma City, the biggest one we've ever had. Indiana's ahead on registration, so you better get registered ASAP. You don't want that to be sold out on you. That's in March 19th. And then come fly fishing with me in Bozeman in July. But thanks, everyone. Mike, thanks for sharing your insights and expertise on ILAs. And I look forward to getting back together next Wednesday. We're going to have our good friend, Ernie Falcone of the California PUC, is going to be discussing broadband competition and pricing strategies in California's urban markets. So they just dropped a study that showed basically when you have more than 1 gigabit provider across California, it would save consumers over $1 billion a year in their broadband service. So bring on all the gigabit providers. Thanks, everyone. We'll see you guys next Wednesday.